from this video, you will learn what is moment of resistance and how do we derive it. Hello friend, I am Samali back with new tutorial video regarding RCC. In my last video, I talked about regarding lever run. Okay, so in case you missed this video, then definitely you find the I button here. Otherwise, you go to the playlist section and check out my last video. So without further delay, let's start the video. So first we understand what is the moment of resistance. So before starting or saying the moment of resistance, I say that this is a beam, UDL is applied on this beam. Then what happens? The bending moment will be generated. And this bending moment due to external load. Okay. And think this way, this bending moment has some maximum value. If this maximum value is resisted by this beam in terms of moment, then the beam will safe. If not, then unsafe. So basically, moment of resistance is that bending moment, definitely internal, which can resist the bending moment due to external loading condition. And this is also combination of what? A combination of compression as well as tension. Why compression and tension? Why? Because we know that load is applied in this way and this is your beam, then the bending profile deflection profile will like that. So if this is your neutral axis, in upper part it will be compression and lower part it will be tensile. So upper part due to compression, so moment should be compression, and lower part as tensile moment will generated, moment should be like tensile. That is why I am saying that combination of compression and tension. Hope the concept is clear. Now comes the mathematics part. How do we derive it? See, moment of resistance. So it is a basically what? Moment. That is the same. We know that moment equal to force into perpendicular distance. This is the symbol of the perpendicular. This is the basic funda. Now how we find the force and how we find the distance. So before jump to the derive, I just start drawing a diagram. This is your tension, this is your compression. Okay. Tension what? Tension stress and compression stress. So how we'll find the force? The force equal to, I can say, stress into area. Right? So stress, it may be compression stress or maybe tension stress. Area should be compression area or tension area. Distance should be either distance due to compression or distance due to tension. Bas, काम खत्म. So bending moment due to compression should be, that is MCOM, that is equal to force into area, force into distance, that is 90 degree. That force equal to stress into area. into distance. See, this is your n by 3. From here, this will be acting. So from this lever point, this is n by 3. So distance would be n by 3. Stress equal to sigma c. What is the area of this triangle? Half into base into height. So yeah, this, if this is your height or base, this is the sigma CVC, and this height is your what? N. So are you agree with me? Are you agree with me? If yes, say yes. If not, then no. Then what occurs? So that should be half sigma CVC into B into N into N by 3. So total equal to half sigma CVC into B into N square, and this is 6. So if you want to remember this value. Otherwise, just go with fundamental, that force into distance. So now it will very much clear to you how you find the moment of resistance due to compression. Okay. So this equal to half sigma CVC into B into N into distance means this lever arm. That is why in last video I talk about this lever arm. Okay. So lever arm value should be D minus N by 3. So equal to half sigma CVC Bn Dn minus 3. Yeah, that's it. So now we'll talk about the moment of resistance due to tension. So I assume that the moment of resistance due to compression is very much clear to you. If not, then definitely due to tension moment. So same, the moment equal to force into distance. That distance is your perpendicular distance. So force equal to stress into area into distance. Distance to D minus N by 3. That is the normal. Stress sigma S into area. Area means the cross section area. Cross section area AST, because tension is generated due to area of steel. That is why AST. D N by 3. And how you find the AST? AST equal to pi by 4 D square, where D is the D, or you can say phi square. Phi is the diameter of bar. Yeah, you can say the D, but D is more universal. It is known as the effective depth. That is why I am not writing the D as the diameter of the bar. So yeah, that is why I am using the phi as a diameter of the bar. Okay. So yeah, this is the your moment of resistance due to tension. But some people do some complex. They love to do anything if it's converted to the complexity. So they can say that, so okay, MP equal to sigma S into AST into B minus N means KD by 3, or MC equal to half into sigma CVC BN D minus KD by 3. Yeah, you can say. So from this, they are saying that M equal to R BD square. R BD square. Why? Because from here you find a D common. So that is here half sigma CBC into B, N means KD, into D square into D 1 minus K by 3. That means half sigma CBC into K 1 by K by 3 into BD. So that whole value is known as your R. This is the extra burden to the brain, nothing else. So yeah, you can go with this, but I will suggest you that just go with the fundamental. This is my humble request. So yeah, this is all about the moment of resistance in RCC. So in this video, I will discuss what is the moment of resistance and how do we derive. Yeah. So yeah, if you find some value from this video, definitely do like, share the video to your circles, friend, and yeah, subscribe this channel for much more content like this. And you face some doubt or problem regarding this, so definitely without hesitation, do comment in comment section because knowledge is the everything that can help you for solving any kind of situation. Yeah, thank you for watching this the beautiful session. See you soon and stay safe, stay healthy.